Hello to everyone, hello and welcome to this, let's say, basic video for us, for engineers. But for most of the people, probably they do not have, let's say, a clue how to start a two-stroke engine of a vessel. So we have some similarities for sure with the small one engines, but when the biggest engines became huge, so huge, like a building, let's say, like a two-store building or three floors building, yes, there is a preparation that we have to do. And I have created also an application as a checklist, which is applicable, let's say, for 99% of the engines, which is very, very easy to use. It is like a, let's say, checklist. And checklists, yes, they're handy, they're very easy to use. Maybe I will upload it also in the App Store, so you're just able, let's say, to tick the things. But an experienced engineer, an engineer that knows the steps, this is what makes it so much valuable, because yes, you know what to be careful. Yes, you know what to check and for what reason to check that. Some things, yes, are simple, but in some cases also they can be really, really complicated if we are forget them. This is where the checklist comes in place. So let's see which things do we have to check before start a engine and how important is that things. I remember always from my academy years that the starting and the stopping of the engine, it is the most crucial thing for most of the machineries. But the engine, this is our, let's say, heart of the vessel, and we have to keep it as much as possible in a really, really good shape. So let's start quickly. First of all, the easiest thing that we are able to determine is the main engine sump tank level. Why it's so much important and why we should always keep the main engine sump tank level in operating levels, in operating normal range. Because there can be two different conditions. It can be the one conditions that we have stop our lubricating pumps, mainable pumps. So we have set, let's say, the purifier for working, and then we are preparing our engine for, let's say, for the departure. And we start our pump, and the level of the engine shows that is not enough. So it goes to the alarm. So what we have to do, we have to feel it. We have to feel it in order to create that operational range. So that's why it starts from there. It starts from the sump tank. So the lubrication system, the lubrication levels, then it goes to the pumps, how these pumps are delivered the pressure. Do we have enough pressure? Do we able, let's say, to compare? Oh, excuse me, excuse me. Yes, we have a power failure here in, yes, in our, let's say, region. Wow. Okay. And it's also destroyed my, um, yes, my presentation. Yes, because I have prepared here. So yes, we are back. I hope yes. I will create another checklist. It's okay. But first of all, yes, as I explained, we start from checking the sump, checking the temperatures. Why it's so much important to have the temperatures um, built? So the reason is because, as you know, the metals expand. So that's why we need to heat up the engines, and we do not like to start them cold. If we start them cold, this is yes what will happen, that first of all, the exhaust gases will go down. They will blow by between the cylinder liner, the piston, and the piston rings. So this is the reason, basically. This is the reason, yes, why we need to heat up the engine, the oil, the engine, the water itself. So the whole system will take its actual working temperatures. This is yes our starting point, and we cannot compare a small engine, yes, with a huge engine. But still, even in the small engine, this is actually the same procedure that we have to keep. So we have a range where there's an operating range, because otherwise, yes, we will damage the engines. Yes, we will damage them. First of all, yes, we will damage through the cold start. The metals also are not prepared as well to work in these conditions, because since you have started an engine, it is directly in ignition. It is an ignition to an application of the pressure to all the directions, to the piston itself, to hello, Ashield. Hello, welcome. Um, And yes, this is basically the reason why we need to heat up. Basically, we are preparing our engine um, for the starting, for the working conditions. This is why it's so much important. And since we are making all that conditions, working conditions, functioning properly, with all the details, basically we will not get that much damage to the engines and to the components. So basically, this is how we prolong the life of the component itself, by keeping the working temperature, by keeping operating temperature. And for sure, all this is done by controllers on the vessel. Yes, we have the controllers. We just set, let's say, the range, the Nakakita, or maybe it can be, let's say, different controller. And this controller will keep that range. Okay, maybe it's, let's say, 72, 74, 75. We have some differences. Also, if we have, let's say, the variation of the load. But since we get the specific load, since we get, let's say, a steady load, not a lot of things will change. That's why the valve will be locked in that position, and it will change only when we will have seawater temperature changes. Yes, PID controllers, yes. And for me, the best system that I have seen, it is the LT and the HT system, not the one that you have, seawater, which cools the engine. No, that one is a completely disaster. Better to have LT and HT. Yes, that is amazing. That is really, really fantastic. So, so we will make a checklist for two-stroke engine starting preparation, let's say, BMW. And yes, if you take the MAN BMW engines, mostly, let's say, common, they have almost similar, let's say, specs for the preparation, also for the operation. Maybe, yes, the electronic engines have higher jacket temperatures. This is the reason, yes, why we need to take additional attention, because, yes, we have engines that are too long stroke, and they have, yes, different temperatures of jacket. It can be even higher, let's say 88, 89, 85. I remember some vessels, in the older vessels, yes, we keep 79, 80, the jacket temperature, and we didn't have any problems at all. But it depends, yes, from the metals, from the engine design, that these temperatures can change, yes. And it is really, really amazing as how these temperatures here are affecting the wall operation, the wear as well of the engines. It is really, really fantastic. So the next thing is we start the lubricating pump, we pressurize, and also we can compare, let's say, number one, number two, which kind of pressure the pump delivers. Is it more? Is it less? And we can compare also the amperage to see, okay, what is the difference in the amperage in both pumps. I would like always to compare, let's say, one set of the pumps with the other set. Let's say number one or number two, yes, how they're performing, what is the running hours, just put them to work equally. And also, one important thing before you start your pump, your lubricating pump, just lock them and switch off, let's say, the power, put a note there that nobody start, and just go down and check the coupling. Sometimes this coupling, it is a rubber coupling. It has some bolts that will lose, and this is how the damage of this pump can occur. You just basically go there, check, and maybe it will require some additional tightening because at the moment it will start, and also while it will be working, probably yes, it will lose its balance through the time because it will not transfer um, the motion properly as required through the coupling. So the couplings, yes, are also one critical and crucial part that we have to take in account on the operation of the pumps. Later on, if we have done, let's say, with the lubricating, with the pressures and all the time, all the checks, with the proper lubricating temperature, proper level of some tank, then we are going to the water, our jacket. We have checked our jacket, we have supplying properly, we have proper pressures, we have the expansion tank filled properly. So all the things, it seems that is, let's say, basic, but yes, what is basic? Basically, it's nothing basic. We have to check, and this is the reason why um, still, yes, the vessels need human. It's always a checking, 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 checking. So at the morning when you come down, this is why the expansion tank, it is located there. It is located exactly on the passage when you're passing down, let's say, and going to the control room from the changing room, and it's exactly there, yes, staring at you, and it says, yes, check me, please, because that is very, very, very important. And what we check also on the expansion tank, first of all, we check the level. The level tells us that if we have any leakages, so it can be determined directly. For sure, yes, they can be, let's say, losses of the water through the expansion and from the evaporation, but also there can be leakages, and these leakages can be determined. Let's say if you see that there is, okay, 150 liters gone per 24 hours, something is going wrong. Something is going wrong. Yes, we probably have, yes, much bigger leakage. The leakage start to increase, and you have to find, yes, where this water goes. Where is it goes? Let's say inside your engine room, or it goes somewhere else. Which is the location? Where the location can be? Is it, let's say, in the air cooler? Is it, let's say, around, let's say, the cylinder liners where these leakage are? The next thing also, because you are starting to lose the water, and also very important thing, you have to know how much water you are filling, because since you start filling, you will have also the loss of the chemicals as well. So the chemicals will be lost. Let's see if I can repair, if I can bring back my application. No, it is erased. Wow. It was really, really nice application, that one that I created, but it erased. Okay. No problem. We will build another one. We will build another one. Let's close it and let's open another one. The next thing that we are looking, it is the air. It is the air, and we found that the air is, it should be clean, it should be without impurities, without water, because this is actually what will pass through our valves, our starting valves, our pilot valves, our main starting valve. So the air should be really, really clean. A checklist for two-stroke MAN BMW ship engine. Okay. Since we have done, yes, I will make for sure for the purifiers as well. Since, yes, we have checked, yes, the oil, the water, the air, that everything is fine. We have filled the air compressors properly. We have all main bottles filled. We have the service air proper, the pressures and the starting air pressures. We have our air compressors, yes, system well prepared. Then we are going to the fuel. Do we have, let's say, the proper fuel temperature? Do we have the proper pressure of the fuel? And also, what we are doing as well, we are turning the engine. We can set the turning gear, turning, and also what we have to do, we have to activate the lubricators. So we call to the engine control room and we say to the officer in charge that, okay, activate the lubricators. While we are turning the engine, we will see also that all the solenoids are working, they are flushing the oil inside, and with this way we are lubricating the engine so it will start much easier. While we are also turning the engine, what we can do as well, we can look to the amperage. We can see if the amperage is changing while we are making, let's say, the whole cycle. What we can determine with that, we can determine that if there is any malfunction to our engine. So if we have any malfunction or any problems to our engine, you will see that the amperage will be increased. That means at that section, the engine takes more power to be rotated. This is the indication. And also, yes, before we start, always before we start any kind of turning, for sure we have to make sure that we have the indicator cogs open, because yes, we do not like to create pressure, overpressure, and also we do not like to overload our turning gear, because in the event, yes, that we will destroy our turning gear, this adds additional effort in order to repair it. Let me see if the checklist is ready. Okay, the checklist is ready. And for sure, yes, before doing that, before start all the things, usually the bridge should call you and say 1 hour notice. This is the most important thing. That the bridge inform the engine that it is ready for standby, ready for preparation, 1 hour notice, that you are ready to start the preparations. So it seems, yes, very easy thing. It seems, let's say, something usual. But if you are, let's say, first time, maybe let's say if you are first time as third engineer, first time as apprentice engineer, first time as second engineer, for sure all the things needs to be repeated again and again in order to making your possession, that you will remember it as, let's say, your left or right hand. Depends also on different kind of equipment. You are probably have to start, let's say, additional equipment. It can be, let's say, stern tubes, probably which you have switch off. It can be also a crosshead loop oil pump. It depends of different variations, let's say, of your engine. And let's see, we have talked, yes, about the air, and also, yes, the hydraulic packs, power supply, the hydraulic power supply for the new electronic engines. This is what we have, let's say, in additional, that we are starting the pump that provides the hydraulic pressure to our system. Without that, yes, we cannot start the engine. Just simply it is blocked, or it is off scan the engine, so it does not start. The next thing, for sure, for the two-stroke engine is to start the auxiliary blowers. The auxiliary blowers will help the engine in the low mode from the start till, let's say, uh, half RPMs, will kick up additionally air, and will give your engine an additional, yes, air that's required, because turbocharger will be turning really slow, and it will not be sufficient for the good combustion that is required. So basically what will happen if one of your auxiliary blowers will get off, you will have much higher exhaust temperatures, and you will not like, for sure, for any reason, to reach the maximum allowable exhaust gas temperatures, and also the maximum allowable exhaust turbine temperatures, because for sure the metals will be stressed, the engine will be stressed, and we do not like this to occur. That's why we have to keep them as well in good shape, take care about them, but also proper lubrication, not over lubricating of their bearings, testing the motor itself to see if the insulation is good, and also very important thing is to not overload them. So by overloading, I mean that you do not have your engine always starting, stopping them, because there is some variations of engines, or um, setup of RPM that goes exactly to that point where the blowers are starting and stopping. Don't do that, because the motors are overheated and they can be damaged. As I explained, yes, the most damages occur when we have the stop and the start of let's say, motor, or an engine itself. So that is it. And then, for sure, after we have all the preparation done, we have the controller, we have the supply power pack, we have the starting. We can turn, let's say, slow the engine. We can do the air blow, as we said, then close the indicator valves, and give the um, give, let's say, the control to bridge, and say that everything is prepared, everything is tested, and let's do, let's say, the test astern and the test ahead. So while doing the test astern and test ahead, we check that the engine is turning properly, that it has a line, it has give the signal to astern or to ahead, and also we are always prepared for the emergency, let's say, shutdown. Um, the auxiliary blowers are taking the suction of the air from the turbocharger. So it is exactly the same filter as the turbocharger. The only thing that changed, when the turbocharger speed up, there is some flaps that are closing, as I remember, yes, which are not allow the air going back. So that's why sometimes in some vessels also you see, because the air is coming from the same port as the turbocharger, you see these auxiliary blowers are turning. If you ask my opinion, turning of the auxiliary blowers, it's not that good, because it destroy its bearings. Okay, this is one of the reason, because I do not like that the air is coming, let's say, from the same exactly location as um, yes, as the turbocharger, because it's turning. Okay, you have friction, and basically these motors are rarely, very rarely working. Hello, Mickey. Hello. Thank you. Thank you very much. And yes, these motors are barely, let's say, rarely working. If you're just going, let's say, slow steaming, okay, maybe you can use them there. And also, if you're going also slow steaming, you have to put them in a range that you are not overloading the motors, the auxiliary blowers. Because since the auxiliary blowers are started, they are going, let's say, to some amperage. But since you increase your RPMs, the amperage also start to increase. Because what happens, you have some air coming from the turbocharger at that moment, and also it presses again, so it creates like a back pressure to the auxiliary blowers, which is not in favor of the auxiliary blowers. So that's why you have to find what is the point, what is the maximum allowable point, and you like as much as possible to pass that point, so your auxiliary blowers will be switched off and you will not have them working together, let's say in the range where the turbocharger is still good enough, and also let's say the auxiliary blowers are working in the same time. But also, if you're very, very experienced, what you can do when you see that you have, let's say, auxiliary blowers running, you have the turbocharger, you have some RPMs, you see this convection pressure, and you can feel that your engine can keep up. So you just switch one auxiliary blower or the second one, and you observe. You observe, yes, if your exhaust gas temperature are increasing. So yes, that is not enough air to your engine, and then you can put them back in automatic. But sometimes, yes, you have to put them in manual and then check, yes, how the system are reacting to avoid, starting and stopping. And also, yes, it's better to know in which range they are starting and stopping, at which pressures. Mostly it is pressure related, yes. When the pressure drops below some level, this is where it gives the signal for the auxiliary blower to start. For sure, everything depends, yes, about the sensors, about the cleanliness of the pipes. So this can also be deviated through the time, through the age of the vessel. So that's why the checking and continuously calibration is very, very important. Why sailing with critical speed for a long time is not allowed? Yes, the critical speed is a point that we would like to avoid, because all the masses that we have in the engine, they are tuning with a frequency, which frequency can destroy the engine. So basically, all the things have its own frequency of operation. The metals have their own frequency, the glass has its own frequency. Since we reach that frequency, where that frequency combines, it is the critical point where it can break down, and it will break down totally, because yes, the metals will reach um, that frequency. Simple as that. And even it can cut the crankshaft. It can destroy the crankshaft. It can destroy, yes, the bearings, because at that moment you can see that this frequency and that metals, all that heavy parts that has the engine that are moving, are making that huge vibration. And this vibration, because the frequency that the engine turns with the frequency of the metals, they go in the same level, and this is where it amplifies. It became so strong that the amplify of the power and the stress to the components became really, really huge. It goes to the maximum. So that's why this critical point, it shows with the red line, and that's why most of the manufacturers, what they're making, you just pass that critical point, so the engine map gives that additional fuel and it passes really, really quickly. You can see that in the RPM meter, that it gives much more fuel or it cuts more fuel in that point that you are not stay that a lot. But it can happen. It can happen that the engine, yes, due to the maneuverability, due to the change, let's say, of the captain, because sometimes captains have the maneuvering not by the orders, let's say dead slow, slow, half, full. They can have it directly to calculate to give the orders precisely by RPM. And this is a very, very dangerous point if they will be lowering, let's say, 1 RPM to the dead slow, or if they are increasing, let's say, 1 RPM. So they can stay for really, really prolonged time in that range, which is not in favor of the engine without knowing that. Because, yes, they do not have this kind of knowledge. So that's why it's better when we are starting or where we are decreasing, we are always use the order of the engine, let's say dead slow, slow, half, full, and navigational full. And then if we would like, let's say, to adjust the RPMs when we are, let's say, far from this critical range and operation of the engine, yes, we are able, let's say, to increase 1 RPM per 2 minutes or 3 minutes. But since we are, let's say, close to that range, yes, we have to use the map of the engine, normal giving order in order to avoid, yes, that unpleasant situation. I had, yes, that case, and I understand, yes, that this is the reason. It is really, really tremendous. It is a really, really bad feeling when you are in the engine room. Everything is shaking, everything, because, yes, this move transferred through the bed plate of the engine and it transfer across all the entire vessel. So yes, the damage can be really, really huge. And yes, the critical speed it is for all the engines, for all the equipment, for all let's say materials. There is a critical frequency. So basically, if you have, let's say, for example, a house, or you have a specific, let's say, building, a, a skyscraper, if you are able to find in which tuning frequency all the structures are tuned, you are basically able to destroy the building without, let's say, physically touch it. So you basically create a frequency which will can be, let's say, a sound. Mostly it can be a sound because the sound is also energy, it is power, and you are able, let's say, to navigate that beam exactly to this building, and this building will be destroyed. Simply as that. Because it will go to its critical synchronization phase and it will amplify the wall structure as it is. Just imagine a building with 1,000 tons just jumping all around just because you reach its um, its exactly frequency that is made. It's similar with the glass. You have seen, just write some videos, let's say glass breaking from frequency, and you will see, yes, how it goes apart just with the sound. And as you can see also, as the engine is turning, it produces also different frequencies, different sounds. So basically, yes, this is how the frequency are being produced from the specific RPMs that the engine is turning. Yes, exactly the same. Yes, exactly the same principle. Yes, exactly the same principle. So as you can see, there is a lot of pre-checks. We can have, let's say, a separate checklist for MC engine, for AMI engine. It can vary, let's say, a little bit, but the main point of the preparation of the engine still stays the same. And there is reasons behind that. It is not, we just not said it just, let's say, for fun. There is specific technical reasons that we have to follow in order, yes, to avoid damages to our engines. And if you will see, most of these things has been developed, let's say, through the problems, from real consequences. Since we are follow these simple steps and simple things, we will not have problems, my dear friends. We will avoid our problems. And since we are able to understand each and every equipment, how it works, why it works, what is the limitations, we will not have any problem. We will just be on the normal maintenance that is required. You know, you do not have to do so much effort. You do not have to spend so much time. It is just learning the basics, just the basics, and for sure they repeat it again. We'll see them again. This is the most difficult part, I believe, to implement the basics in most of the professions. But yes, if we would like, let's say, to develop further, we have to do, let's say, some investigations. Yes, for what reason is happening, for what is happening. Okay, maybe there is, let's say, a service bulletin that is around there, and hopefully, MAN BMW has, and all the engines, yes, has done investigations, and then yes, you discover that this is the reason. Let's say it is a technical design problem, it is another problem, it is that problem, this problem. There's a lot of different things, but the only thing, yes, that you have to have is just, um, a little bit interest on that. So, my dear friends, I do not like to make it so much extensive, but I hope you like this video, because this video, it describes, let's say, more details. It is more, let's say, focused in the engineering world. And what I have understand that, I have, let's say, deleted some of the videos about, let's say, complaining for the seafarers and all the thing. I believe, yes, I will change my direction. I will change my direction mostly to help and support to resolve the problem, but not just much, let's say, to preview, let's say, the bad side of the shipping. Okay, just mostly focus on the resolving the things and how we are able, let's say, to improve them. This is, I believe, will be my stance from now. And yes, that is it, my friends. Thank you very much. And see you in the next video or live. Bye bye to everyone.